This is Lesson 9.1, Adding and Subtracting Polynomials. Well, first we're going to look at some definitions for monomial and polynomial. A monomial is a number, a variable, or the product of a number and one or more variables, with whole number exponents. A monomial is one term, but more specifically, that one term cannot have negative or fractional exponents. It cannot have a variable in the denominator. So there are some specific rules about this one term. When we talk about a monomial, a lot of times we look at degrees of monomials, and a degree is the sum of all the exponents of the variables in the monomial. The degree of any constant term is 0, except for 0 itself, and that does not have a degree. So I put this table up that you'll also find in your textbook. And on the left-hand side in this first column over here, you're going to see monomials listed. We have 10, 3x, 1/2 ab squared, and negative 1.8 m to the fifth. Again, those carets represent exponents, just like they do in your calculator. The degree of the monomial for 10 is 0. Okay, because the rule up top here is that the degree of a non-zero constant term is 0, so you'll see that degree is 0. The degree of 3x is 1 because x is raised to the 1 power. Remember, it's the sum of all the exponents of all the variables. In the third one, 1/2 ab squared, you have the exponent of 1 for a and 2 for b, so the degree is 1 plus 2 or 3. And the last monomial, the negative 1.8 m to the fifth, the degree there is 5. Now what's not a monomial, if you look in the third column, 5 plus x, sums of anything or subtracting anything is not a monomial. 2 divided by n, that variable cannot be in the denominator monomial, so that doesn't work. 4 raised to the a, the variable cannot be the exponent in a monomial, so that doesn't work. And the last one, x is raised to the negative 1, the variable has to have a whole number exponent. And remember, whole numbers are positive, so no negative, 0, or fractions can work here. A polynomial, on the other hand, is a monomial or a sum of monomials. Each one is called the term of a polynomial. So it's usually more than one terms, although a monomial is a polynomial. When a polynomial is written so the exponents decrease from left to right, the coefficient of the first term is the leading coefficient. So I put the example of a polynomial here. Polynomials are always written in decreasing exponents. So you start with the term with the highest exponents first, and then you go down to the constant. So here we have 2x to the third plus x squared minus 5x plus 12. Let's start from the very end. We see that 12 here is the constant term. That means it's a number without a variable. That makes it a constant. The degree of the polynomial is 3 because degrees of polynomials is the degree of the highest term. So in this case it's the third. And the leading coefficient is 2 because that's the coefficient before the first term, the one that leads the string of terms. So here's an example. They want you to write 15x minus x to the third plus 3 so that the exponents decrease from left to right. Then they want you to identify the degree and the leading coefficient. So take a look at that for a second, see if you can do that. Alright, so let's take a look here. I'm going to slide this down. In this case, you have an x to the third term. That has to go first because that's the highest exponent. So it's negative x to the third plus 15x. You don't have a squared term, so the 15x goes next, plus 3. So the degree is 3. That's the highest exponent. The leading coefficient is the coefficient of the first term, so that's negative 1. We take a look at the next one. Let's write 3b to the third minus 4b to the fourth plus b squared so that the exponents decrease from left to right. And then identify the degree and the leading coefficient of the polynomial. Look at what the highest exponent is. That has to go first, followed by the next highest, and so on. In this case, you're going to start with that negative 4b to the fourth. That has to go first, plus 3b to the third, plus b squared. So the degree here is 4. That's the exponent of the leading term. And the degree is 4, right? And the leading coefficient is negative 4. Sorry about that spelling error there. Let's take a look at the next slide. To add polynomials, you have to add the coefficients of like terms. And remember, like terms have the same base and they're raised to the same exponent. That's what a like term is. So 2x squared plus an x squared. You can add those together because the x squareds are the same. Yes? Alright, so to add, you can do it either in horizontal or vertical format. I usually do it horizontally because I don't like to rewrite the problem, but you might find that vertically makes more sense to you. So we're going to look at both of them here. In horizontal format here, we're adding 2x cubed minus 5x squared plus x plus 2x squared plus x to the third minus 1. So you take all those raised to the third terms, those x to the third terms. We have 2x to the third and x to the third. That's 3x to the third. Remember, when you have like terms, when you have the same base, you're adding their coefficients when you add them together. You don't fool around with the exponents at all. And then it's a minus 3x squared because you have a minus 5x squared plus a 2x squared. So it's minus 3x squared plus x minus 1. Now in vertical format, here's another problem. We're just going to line up the like terms and then we're going to add them together. So write them in descending order first and then line them up. So on the top row, we have 3x squared plus x minus 6. And on the second row, we have x squared plus 4x plus 10. When we add those together, we get 4x squared plus 5x plus 4. So you choose the method that you like the best. Both of them work equally well. Now to subtract polynomials, you do the opposite. I usually just subtract each term in the second parentheses, but one way that the book suggests that you do it is to multiply each term that you're subtracting by -1 and then add them, as if that would make it easier. I think that might make more mistakes, but that's up to you to try that if you want to. We're going to find the difference here. We have 4n squared plus 5, and we're subtracting -2n squared plus 2n minus 4. Now remember, when you subtract a whole group of terms, a polynomial in the parentheses, you're subtracting every single term that's in there, so make sure you apply the negative to each one. So we have 4n squared minus a minus 2n squared, so it's plus a 2n squared. That becomes 6n squared. We have no n term in the first group, so we just keep the minus 2n. And then we have 5 minus a -4. That's a positive 9. Why don't you try this one? We have 4x squared minus 3x plus 5 minus 3x squared minus x minus 8. Take a second and see if you can do that one. Remember to just subtract like terms. When you subtract, you actually get x squared minus 2x plus 13. The only tricky part was the minus 3x minus a minus x. That's a minus 3x plus x. That's how we got minus 2x for the middle term. And then you have 5 minus a -8. That's 5 plus 8. That's how we got 13 there. If you did that incorrectly, why don't you take a look at it and make sure you can recreate it. Let's take a look at a word problem. We're going to look at baseball attendance. So, Major League Baseball teams are divided into two leagues. From 1995 to 2001, the attendance N and A. N is for the attendance in the National League, and A is the attendance in the American League, can be modeled by these two equations. So the attendance in the National League is negative 488t squared plus 5430t plus 24,700. And in the American League, it's negative 318t squared plus 2040t plus 25,600. That should be a 600. So let me just fix that. 600. And here T is the number of years since 1995. What they want to know is about how many people attended Major League games in 2001. Well, the first thing you have to do is get an equation for total attendance. So the way you want to do that is add those two equations together. We're adding N and A together. So you add the T squared terms, the T terms, and then the numbers. And when you do that, you get negative 806T squared plus 8,470T plus 50,300. Once you have the expression for total attendance, you have to substitute a number in for T. Well, because they're asking for the year 2001, that's 6 years since 1995, so we're going to substitute 6 in there. So the total attendance becomes negative 806 times 6 squared plus 8,470 times 6 plus 50,300, and the total attendance then is 72,100.